Hello everybody and welcome to the Carlam Cymru revision sessions. This session will focus on the higher tier maths GCSE and will be presented by Mr Alan Walters from Gowerton School. The session will last around 45 minutes where Mr Walters will run through the relevant subject content. If you have any questions during the session, please use the question and answer section within this live event and we'll do our best to answer your questions. The session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carlam Cymru tab. Thank you, Mr Walters. Over to you.
Thank you. Hi, everyone. First of all, then, what I must say is that it's a webinar, and if you feel the need to pause the video, pause it, try the questions, and after that, then press play, and I will endeavour to answer the questions for you. So moving on to the first sort of slide, there's 3 questions there. If you wish to try them, pause and then play in a moment. Okay, I will crack on straight away to answer these. Right. So the first question is a simple rectangle, and we're trying to find the area, and it's just the area equals 8 times 6, 48, and we say meters squared. The second one, you must ignore the 5. The 5 you would use if you were trying to find the perimeter. The area of the triangle is a half times the base, which is 8, times the height, which is 3. And you can say a half of 8 is 4, and 4 times 3 is 12. And again, it's meters squared. Okay. Now down the bottom, you would need a calculator, and you do need a calculator for today's work. I'm going to use the pi key on the calculator. You might want to use 3.14, but I'm going to use the pi key. The area of this particular shape, this circle, is pi r squared. That is a formula that will not be given to you. And you work out the area then just by saying pi, use the pi button on the calculator, times, and we are given the radius. Sometimes you're given the diameter. We are given the radius in this case, so 4 squared, and then you work that out to be, to 1 decimal place, 50.3 meters squared, which I've got a sheet of paper here that you would have to tap out on a calculator. Okay, so we're going to use those skills today. Something else we're also going to use is that we're going to work out the circumference of that circle. Okay, so if you were trying to find the circumference, you'd use a different formula. You would use, I use pi times d. Some teachers use 2 pi r. Okay, we'll get to the same answer. The circumference is equal to pi times the diameter. The diameter is 8 meters. It's double the 4. Okay, so you would say pi times 8. You would tap that out on a calculator, and you get 25.1. Now this is a distance, so it's 25.1 meters if you were asked to round it to 1 decimal place. Okay, so we've looked at a rectangle, a triangle, and a circle, and we're tending to use a lot of those today. Okay, so we're going to look at surface area first. Now the surface area is, if you were going to paint the outside of that box in a different colour, it's a cuboid, so there's 6 sides. Some people work with multiplying. I like to work with 6 separate values that I'll then add up. Okay, so if you want to pause the screen, do so. Otherwise, I will give you the answer here. Okay, so what I tend to do is I label the sides A, B, and C. So if I call this side A, the front face for me, 5 across, 3 down, because there's 3 there. So I write A equals 5 times 3. And there's another A at the back. So I'm not going to work that out, but I'm going to write 15 there. So A at the front and A at the back. Then I'm going to call this side B. That's on the right. So B is 4 that way and 3 tall. So it's 4 times 3, which is 12. And there's a B on the left-hand side over there. Okay, so B is also 12 on the left-hand side. Then we've got the top, which I'll call C. And C is 5 in that direction and 4 going back. So it's 5 times 4, which is 20. And there's another C at the bottom. 6 sides in all. Okay. If you don't get 6 sides, then you'll have to check what you've missed. Make sure you add them, because you're not telling the examiner just that you're adding them just by putting numbers on top of each other. You show a big add up sign, and when you add them all up, you will get 94. And in this case, it's centimeters squared because it's an area. Okay, so that's the surface area of that particular cuboid. Now, sometimes in the exam questions, we just talk about, say, a swimming pool or a box without a lid. So you might only have 5 sides then instead of 6, but that's one to watch out for later on when we do the exam questions. Okay. Now, on this occasion, I'm telling you what the volume is, but I'm asking you for the surface area of that particular cuboid. Okay. Now, the volume is 60, so for a cuboid, you would multiply the volume is multiplying the 5 by the 4 by the distance y, and it's 60. So what I've done is I've multiplied the length by the breadth by the width, or whatever you wish to call each dimension. So 20 times something is equal to 60. So that value of y is equal to 3 centimeters. Okay, so you're working backwards. You're given the volume, you're given the length and the width, and you work backwards. Now, if you've got the height, you're now into the setup where you can work out the surface area. Now, this happens to be exactly the same size. This cuboid happens to be exactly the same size as the cuboid above. So I'm not going to go and work it out because I've already worked it out. The surface area is 94 centimeters squared because it's an area as above. But in an exam, you wouldn't be working that out above. Okay, so we've worked backwards where I find out the missing length and then I go on and work out the surface area. Right, there's an exam question here. So there's a little bit of reading you have to do before you can access the question. Okay, so I'm going to highlight 1 or 2 things. And if you wish to try it, you try it and pause the screen. And I'm just going to highlight a few things. I'm going to pause for 30 seconds and then I'm going to do the question, but you pause for longer if you wish. If you haven't had enough time, pause the screen. If you have, this is how it's done. So I'm going to say the distance across is 6 centimeters. You may have chosen another distance back here to be 6. I'm going to call this 4 centimeters and you may have called it 6. But this is important. The height is not 1 centimeter tall, it's 3 centimeters tall because we've got 3 boxes stacked on top of each other, okay, as it says there, stack of 3. So now I've got the 3 distances, so we're going to go through the process exactly like we did in the question earlier. So I'll call this side A. We're talking about the whole side. And A is 6 across, 3 down, and there's an A at the back. There's a side B, I'll call this side B. Like I did in the first question, and it's 4 going backwards and 3 tall, so it's 4 times 3. And that's on the right hand side, and on the left hand side, it's the same. And then we've got the top, which I called C. And C is 6 across and 4 back. So 6 in that direction and 4 back. So 6 times 4 is 24. It's exactly the same at the bottom. And as I say, big plus sign there, tell the examiner what you're doing. Otherwise, if you have made an error there, you won't get any method marks. But assuming you've done everything correct there, I do believe that that all adds up to 108 centimeters squared. Okay. And that's the end of that question. Okay. Now, if you didn't make it 3 centimeters tall, you would get a number of marks, but not all the marks, because you've missed the fact that there's a stack of 3. So the next question. Another exam question, you're asked to find out the surface area of that triangular shaped prism. And then it's more of a numeracy type question where 1 tin of paint covers 150 square centimeters. And we've got 30 of the boxes, and it's asking how many tins of paint Anne would need. So what you would need to do is work out the area, the surface area, and remember now there are 5 sides. There are 2 triangles there at the front and at the back, and then you've got 3 sides. There they are, 1 at the back, the sloping side, 2, and then 3 at the base. So I'll leave you try that question a moment. I will pause for ever such a short time, and then I will show you, but you can pause for a lot longer. Okay. The triangle at the front has, I'm just going to do a little triangle here rather than call it A, B or C. The triangle at the front has an area of half, the base is 4 and the height is 3. Be careful not to use this 5. I'm not interested in the 5 for the area of the triangle because it's the base times the perpendicular height. So that gives us an answer of 6 centimeters squared. I'm going to draw the other triangle at the back, which is exactly the same. Now, what we do next, it's difficult to draw on here and say 1, 2 or 3 for the sides or A, B or C because it's like a see-through shape. So what I'm going to do here is I'm going to call it the sloping rectangle. The sloping rectangle is 7 across by 5 down. So if I looked at it from an angle, it's 7 is the base, the height is 5, which is 35. Okay. So the back, which is this face here, that's the back. The back rectangle is 3 tall and 7 in that direction there. 3 times 7. Actual fact, I'm going to keep it the same. I'm going to say it's, pardon me. I'm going to say it's 7 by 3 tall, which is 21. And then we've got the base, right? The base is also a rectangle, and it's 7 across, and it goes back 4. So it's 7 times 4. So I've got 3 rectangles, all of different sizes, and 2 triangles which are the same. So once again, a big plus sign. I'm adding up all of those to get the marks for the method. And if you add them up right, you'll get 108, and it's centimeters squared because it's a surface area. Okay. Now I haven't finished the question because it says there's 30 boxes. So each box is 108 centimeters squared. Sorry, I haven't added those up correctly. It's 96. Gone back to the last question, unfortunately. When I add those up correctly, let's just check again. 6, 6, 35, 21, and 28. It gives us 96 centimeters squared for one box. Now there are 30 boxes. So for 30 boxes, it's just simply a case of 30 times 96. You tap that out on your calculator to get 2880 centimeters squared. So that's the surface area of 30 of these boxes, these confetti boxes. Okay, so we're asked how many tins of paint, and each tin covers 150 centimeters squared. So what we need to do next is divide. What we do is this: we divide number of tins the area of the 30 boxes divided by the amount of area one tin of paint covers. When you tap that out in your calculator, it gives you an answer of 19.2. Now 19.2 is not how many tins of paint will Anne need. Now 19 tins is not enough. There's no such thing as being able to buy 19.2 tins. So we need to buy 20 tins. That's how many tins you would need to buy to paint 30 of those triangular shaped boxes. Okay, so if you need more time on that, pause the screen. I'm going to go on to the next question. Okay, I'm going to highlight one or two things here, and if you wish to pause the screen and have a go at it, I'd like you to have a go at it. The key bits of information I'm highlighting. Right, what we're going to do here is the surface area of this packaging that goes around the outside like that. This is the surface area that goes around the outside. So what we've got, if you unravel that packaging, it's a rectangle, and the rectangle will have a height of 7 centimeters, and then it has a circumference here, the distance all the way around this circle, and I won't try and draw all the way around there, but the distance all the way around is the circumference. It's not given to you, you have to work it out. So the circumference of a circle is pi times d. That formula is not given to you. or some people prefer to use 2 pi r. So the diameter is given to us on this occasion, so it's probably easier to use pi times d. The circumference of that packaging that goes round the outside is pi times 12. Now I'm using the pi key on the calculator, and I've got an answer of 37.699,111,84. Now I'm not going to round it at that stage because we only round at the very end of a question. So I'm going to replace that circumference up there with the circumference I've just worked out, which is 37.699,111,84. So having worked out what the circumference of the cylinder is, and the height is 7, it's a very easy rectangle calculation for the surface area. So the area is the base, which is this number, and I would suggest you just leave it on the calculator screen. That's the base, or the circumference, times the height is 7. When I tap that out on a calculator, I'm now going to round it to 1 decimal place. I get 263.9 centimeters squared. This is the appropriate place to round it to 1 decimal place because this is the end of the question. Okay. Word of caution again, do not round that to 36.7. If you use 36.7, you will get a different answer to the answer that appears down there. Save your rounding to the end. Okay, so now we're going to go on and have a look at a few volume questions. You are given this formula on the front page of your exam paper, amongst other formulas. So it's the area of the cross section. I call it the cross-sectional area times the length. So this is the first shape. You can have a go at this now and then play back when you're ready. So if you've tried it, the cross-sectional area in this case is a triangle. So I'm just going to say a half times the base is 6 times the height is 5 and 3 times 5 is 15. Okay, so that's the area. Now the volume, as quoted at the front page of your exam paper, which is there, cross-sectional area times the length, or the area of the cross-section times the length. So I'm going to use this 15, which is the area of the cross-section, times the distance it goes back is 10. So in this case is 150. Now it's volume. So we are now talking centimeters cubed, because a volume is measured in 3 dimensions. Okay, so that's the first question, and that's pretty bog standard. The second question, you are told the volume, but you have to work back to find this missing length. Okay, so there are a few ways you could look at this. You could consider the volume using cross-sectional area times the length equals the volume. Or what I'm going to do on this occasion is I am going to use the formula volume is cross-sectional area times the length, but I'm going to write it in the way I would prefer it. Cross-sectional area times the length, or the height, is equal to the volume. Okay, now I've got the length back is 10. The cross-sectional area times 10 is the volume, which is 150. So obviously the cross-sectional area is 150 shared by 10. The cross-sectional area is 15. So what I got now is a triangle where the cross-sectional area is 15. This is a triangle and the cross-sectional area is 15 centimeters squared. So now I'm going to use the area of a triangle, which you could use the base times the height and then share by 2, or this one here, a half times the base, which in this case is y, times the height is 5. So that's what I'm using for the area of the triangle. Half times the base times the height equals, and I'm going to use the cross-sectional area 15. So a half of 5 is 2.5. 2.5 times y is 15. Now, if you divide y by 15, you get 6. Now, 6 centimeters, it's a distance we were trying to find. Okay, so that's the way I've chosen to do that question. You may try and find y from using the whole volume question, whole volume formula. Okay. So the next question is this, and I'm going to ask you for the volume of this. So pause and play when you're ready. This is the triangle, and quite simply, the cross-sectional area is a half times the base, which is 40, times the perpendicular height, which is 30. Leave that 50, it's not needed. Okay, so a half, 40 is 20, and 20 times 30 is 600 centimeters squared for the area of the triangle. Now that 50 is definitely not needed. You would need it if you were finding the surface area, which I'm not on this occasion. Okay, the volume using the formula that's on the front page of your exam paper is the cross-sectional area times the length. Cross-sectional area just worked out to be 600. The length is the distance back, which is this, 60. And 6 6s are 36. 3 noughts on the end. Okay, and notice this question is asking for the units of your answer. So when this is marked, there will be a mark for saying centimeters cubed. And the next question. Okay, so we are asked to find, I'll read it and highlight things first. Right, so that's the typical box there. We want the volume of the box. And then, right, we'll pass a comment then on whether it's greater or less than 3 litres. Okay, so the same formula again. We're going to work with this distance. The base is 8 and the height is 6. Now, if that's a little bit on the small side, I will enlarge that for you. So the cross-sectional area is a half times the base is 8 and the perpendicular height is 6. So that's 4 times 6 is 24 centimeters squared is the area of the triangle. Now, something that catches people out, the distance back is said here to be 1.3 meters, but we are working with centimeters there. So I need to change the 1.3 meters into 130 centimeters. Okay, so when you come and work out the volume, which is the cross-sectional area times the length back, cross-sectional area is 24 centimeters squared, and the length back is not 1.3, it's 130. So when you tap that out on a calculator, you get 3120 centimeters cubed. Right, so is the volume of the box greater or less than 3 liters? So we need to know what 3 liters is. Now, 1 liter, you will need to know, is 1,000 centimeters cubed, or 1,000 milliliters, but in this case, 1,000 centimeters cubed. So 3 liters is 3,000 centimeters cubed. So I am comparing 3,000 with 3,120. So I'll go back. Is the volume of the box greater or less than 3 liters? So it's greater than 3 liters by, and you could do a takeaway here, 3,120, take away 3,000, and it's 120 centimeters cubed. So the volume of the box is greater than the 3 liters by 120 centimeters cubed. The next question, okay, is to do with circles, or it's a cylinder. So we mentioned the area of a cylinder, or the area of a circle, is pi r squared. So in this case, the radius is 6 centimeters. So we are asked to find out the volume of that. So the volume now, the cross-sectional area times the length, right? The cross-sectional area is pi r squared, right? In this case, pi times, we are given the radius of 6. Sometimes we have to work with the diameter, so 6 squared, and you get a value of, I'll leave it as 36 pi for now, because further down here we say that the volume is equal to 36 pi times the height, or the length, is 10. When you tap all that out on a calculator, you get 1130.9733. If I was working to 1 decimal place, it becomes 1131 centimeters cubed. 1 decimal place. Right, the question below. Just wondering, could come back to this question. Right. I'm going to come back to this question in a moment. It's very similar to one we did earlier. I'm going to do this question. No calculator allowed. So we have to write down the volume, right? And we have to leave it in terms of pi. Now this is quite regular in a paper one. Sorry, I mixed it up with another question. We are using the value of pi is 3.14 here. I'm going to leave that a second. This is the one I'd like to do, right? Okay. A concrete base for a bungalow. So this is where we work out the area, the floor space of the bungalow first, and then we multiply it by the thickness. The thickness is 0.2 meters thick. So everything's in meters. So if you wish to try it, you can try it first. I'm going to show you what I would do. I'm going to call that A and I'm going to call that B. So it's a compound area. The area of A from the plan, that is the plan of the house. The area of A is 4 times 5, which is 20. The area of B, be careful which numbers you use. Ignore the 20 there. We're using this 15 and this 15. 15 times 15 is 225. So the total area, the total cross-sectional area is, we are adding them. So make sure you put an add up sign there. And we get 245 meters squared. So the floor area of Miss Morgan's house is 245 meters squared. So the volume of the concrete base, which is 0.2 meters thick, go back to our usual formula. The volume is the cross-sectional area times the length. So the volume is our answer from the floor area, 245, times the thickness of the concrete is 0.2 meters. When you tap that out on a calculator, you get 49 meters cubed. Okay, so we worked out the floor area by splitting it into an A and a B. We put a big add up sign to show we're adding them. We've got a total cross-sectional area. And then we multiply that area by the thickness, which is 0.2 meters, and we got 49 meters squared. Okay, so I think the next one, I'm just wondering if this is a similar sort of question, but we're not talking about the floor area now, we're talking about the step. Okay, so there's enough information there. But unfortunately now this becomes more difficult. We have to work backwards as follows. All right, so if you wish to try it, pause the screen. I'm going to point out has a uniform cross-sectional area. The volume is 66,000 centimeters cubed, and we want the length of the step. So what is missing is this distance here, the length. Okay. So pause the screen and have a go. It's a little bit harder than the other ones. I'm going to work out the cross-sectional area first. So I'll split it up into an A and a B. This is A, this is B. You may have split it up another way. So I'm going to say A is equal to 20 by 24. And it's 480 centimeters. B, now the distance from there to there, I get from adding 25 and 20, 25 and 20 being 45. So what I've got is that it's 45 along the bottom. And this distance tall here, this distance is found from 24, take away 50, 24 is there, 50 is there, I'm left with 26 tall. So this is quite an awkward one to work out. It's 45 times 26. So I'd have a look at that very carefully. It's 1170 centimeters squared. So I'm adding up A and B, show that add up sign. So the total cross-sectional area is equal to 1650 centimeters squared. So I was able to work out the cross-sectional area. I am told the volume. So I'm going to, instead of saying cross-sectional area is, sorry, volume is cross-sectional area times the length, I'm going to say the cross-sectional area times the length is equal to volume. I know the cross-sectional area is 1,650. The length is what I'm trying to find. The volume, I'm told, is 66,000. So if I divide the 66,000 by the 1650, I get that the length is equal to 40 centimeters. Okay, so that's a question where we work backwards. We have the cross-sectional area, which was quite awkward to work out the dimensions for B. Once you got the cross-sectional area, then you're using this formula, but I'm arranging it in the way so that I leave the length on the left-hand side. Okay, so I'm just trying to see now which question to do next. Right, I think I've got time for one more question. And the one I'm going to do is this. Sometimes, especially in numeracy, they say that water flows into a tank at 5 litres per minute. So the volume of the tank, first of all, multiply the three distances, 50 times 40 times 35, which is 70,000 centimeters cubed. It's actually 70 litres, right? Now, down here, they're saying that a tap water flows into the tank at a rate of 5 litres per minute. How long does it take to fill the tank? So the time taken is the 70,000 divided by 5,000 for every minute. And 70 divided by 5 is 14 minutes. Okay, so that would be a typical numeracy type question. So there are other questions there that will be posted with their solutions. I'm posting them at the end of this session. I've got something I need to inform you about, right? And that's the end of the maths session for this term. Good luck to everyone who's sitting the GCSE exams next month. And remember that Callum Cymru revision sessions will be back next term. So look out for the details on the e-sgol website. And goodbye for now.